So welcome to all of you. So we'll go to the chapter 4, that is numerical solution of the first order differential equation. So why it is called our first order differential equation means what? So the order of the differential equation is the highest order derivative occurring, the order of the highest order derivative occurring in the differential equation. So that is the order of the differential equation. So now the differential equation contains only the first order derivative, then the differential equation will be the first order differential equation. Okay, and now in this chapter there are five methods are there. So how to solve the differential equation with the help of that method? Numerically we have to solve that differential equation. That means what here, suppose we have given the differential equation dy by dx is equal to f of x y, something like this. Initial condition is also given to you and you have to find some y of 1.1 like this. Okay, so we have to find the value of y of this one. So that means what we have, there are several methods how to solve the differential equation. So variable, separable and so on. We are not using that method here. We want a numerical solution. We want what? Y of 1.1 and so on. Okay, so the first method is the Taylor series method. We will explain the Taylor series method for solving the first order differential equation. Okay, let the differential equation be y prime is equal to f of xy. Okay, so that is dy by dx is equal to f of xy. I'll call this as 1 with initial condition y of x naught is equal to y naught. Y of x naught is equal to y naught. Okay, so let y of x be the exact solution of 1. So then y of x has Taylor series around x is equal to x naught. That is what y of x is equal to a y naught plus x minus x naught dy by dx at x is equal to x naught plus 1 upon 2 factorial x minus x naught square d2y by dx square at x is equal to x naught plus 1 upon 3 factorial x minus x naught cube d3y by dx cube at x is equal to x naught plus dot dot dot. Okay, okay, so this is nothing but y of x is equal to y naught plus x minus x naught y naught prime, this is y naught prime, plus 1 upon 2 factorial x minus x naught square y naught double prime plus 1 upon 3 factorial x minus x naught cube y naught plus dot dot dot. Okay, so we'll call this as a 2 now. We'll call this as 2. Okay, if we know the values of y naught prime, you have the values of y naught, no problem for this. So we'll write y naught prime now. Okay, instead of this y naught prime, y naught dot dot dot, then y of x is a power series for y. Okay, so this will be the solution of the differential equation. This. Okay, so you have to find y naught prime, you have to find y naught double prime with the help of the given condition, and we'll put the value of here. We'll get a power series of y of x. And if you want to find y of some 0.1, just replace x by that power 1.1 and so on. So you will get a solution of the differential equation. Okay, so we will see. This is the method. This is a very simple method. Taylor series method is very simple method. Only I have to remember this. Only I have to remember this equation 2 only. Okay, so you have to remember only this equation 2. So in 2 you have to find y0 prime, y0 double prime and so on. You have to find this derivative and put here. You will get a solution of the differential equation. And if you find y of 1.1 something like this, just replace x at 1.1 and so on. You will get the solution of the differential equation at x now. Okay, whatever the x may be. Okay, so we will take an example so that you will understand how to solve the differential equation by using Taylor series. Okay, so we'll take an example. Solve would y prime is equal to x minus y prime with y of 0 is equal to 1 by Taylor series method. And find y of 0.1 correct up to 4 decimal places. Okay, solution. Given that y prime is equal to x minus y square. This is y square. X minus y square. Y of 0 is equal to 1. Okay, given that we write this what with y of 0. This is the initial condition. Okay, so therefore here what f of xy is equal to x minus y square. Your x naught is 0, your y naught is 1. Okay, so by Taylor series y of x is y naught plus 1 plus not 1 up here plus x minus x naught y naught prime plus 1 upon 2 factorial. Just we write the solution. X minus x naught square y naught double prime plus 1 upon 3 factorial x minus x naught cube y naught prime plus 1 upon 4 factorial x minus x naught 4. So this is what y naught 4 plus dot dot dot. I call this as 1. So what I want to find the values of y naught prime and so on. Okay, so we will not call this as 1. This is the formula. Just here what x naught is 0 now. So x naught is equal to 0. Okay, so therefore what y of x is equal to y naught plus x y naught prime plus 1 upon 2 factorial x square y naught double prime plus 1 upon 3 factorial x cube y naught triple prime plus 1 upon 4 factorial x to the power 4 y naught this plus dot dot dot. I will call this as 1 now. Okay, so if I got the values of y naught prime, y naught double prime and so on, we will get a power series of y of x. That is the solution of this. Okay, this is a numerical solution of this. Okay, and then we will put x is equal to 0.1. Then we will get the value of y of 0.1. Okay. Okay, so we'll find this. Okay, so your y naught. What is your y naught? Y naught is 1. Okay, so y naught prime. So this is your y prime. So y prime is what then? X is equal to what is your x? X is 0 now. Minus y prime. Y is what then? Y naught prime is 1 square. So this will be 1. Your y naught prime is 1 now. Okay. So y double prime. First we will find y double prime. Okay. So y double prime. We have y prime. Okay. So we will write here y prime. Y prime is equal to x minus y square. Okay. We will differentiate this. So derivative of x is 1 minus derivative of twice y y prime. So this implies that y naught double prime is equal to 1 minus 2 y naught prime. Okay, so this is what then 1 minus 2. What is your y naught? Y naught is 1. And what is your y naught prime is minus 1. This is minus 1. Okay, so this is minus 1. So this is what then 3. Okay, so we'll find the third derivative now. We'll find the third derivative. third derivative. So y third derivative. So y double prime is this. The second derivative. We differentiate derivative of 1 is 0. So minus 2 will be common. So y double prime. Derivative of y prime is y double prime. We have to apply the product rule. So y will be as it is. Derivative of y is y double prime plus y prime as it is, and derivative of y is y prime. Okay, so this is minus 2 y double prime minus 2 y prime square. This is minus 2 y prime square, minus 2 y prime square. So we write y prime square as like this. Okay. Okay. Now this implies that y naught double prime is same as what? Minus 2 y naught double prime minus 2 y naught prime square. Okay. So this is minus 2. Y naught is what? Y naught is 1. Y naught double prime just we have calculated, that is 3. Minus 2. Y naught prime is minus 1. So minus 1 square. So this is what? Minus 6 minus 2. So this is minus 8. So this is minus 8. Okay. So now we find we'll find one more term now. The fourth derivative we'll find. Fourth derivative. Okay. So at least 4 terms we should get here. At least 4 terms we should get here. So we'll find y4. So if y4 is 0, then we'll find y5 then. Okay. So now we have to differentiate this. So this is the derivative. We have to differentiate this. So what we'll do? Minus twice common. Okay. It will be as it is. So you have to apply the product rule. Your y will be as it is. Then the third derivative plus your second derivative as it is into y prime now. Okay. So this part is complete. Okay. Derivative of y double prime is complete. Minus this is what? 4 y prime minus 4 y prime into y double prime. Into y double prime. Okay. So this is the derivative. Okay. So here we can simplify this. So that is what? Minus 2y third derivative. Then this is minus 2 and minus 4. So this will be the minus 6 y prime y double prime. Okay. So now we'll find the fourth derivative y naught now. This will what? Minus 2 0. Minus 2 6 y prime 0. Y double prime 0. Okay. So minus 2. Okay. So what is the third derivative? Third derivative is minus 8. This is minus 8. Minus 6. Y naught prime is minus 1. Y naught prime is minus 1. And y naught double prime is 3. Y naught double prime is 3. Okay. So this is what? 16 plus 18. So this is what? 24. Oh, not 24, 34. This is 34. Okay. So in this way you can find a 5. Okay. So for trial error we will find a 5th derivative also, so that you will understand how to find a 5th derivative also. Okay. So now this is your 4th derivative. Okay. So what is that? We differentiate that. That is what? Minus 2y. This is the 4th derivative. Minus 6. We'll keep y prime as it is. And we'll take this will be the third derivative. Then minus 6 y double prime square. It will be y double prime square then. It will be minus 6 y double prime. Oh, this is not. See y double prime again. This one it is square then. Okay. So 5th derivative at y naught is what then? Minus 2. 4th derivative at y naught. Minus 6 y naught prime, y naught third derivative, minus 6 y naught double prime square. Okay, if you want, then you can do. Okay, so this will be minus 2. This will be minus 2. The 4th derivative, just we have calculated, the 4th derivative is 34. So this is what? 34 minus 6. Y naught prime is minus 1. Third derivative just we have calculated. This is minus 8. minus 6. Y naught double prime is 3. So this is 3 square. Okay. So this will what? Minus 68 minus 68 minus 48 minus 48 minus 54 minus 54, and it will be minus, all are minus here, so minus 186 minus 186. So this will what? Minus 186. We'll check the derivative. This is what? Minus 2 Oh, here we miss, this is y. We miss here y. Minus 2y. Okay. We miss here y. Okay. So here what? There should be the y naught now. So minus 2 y naught. So this is what? Y naught is what? Y naught is 1. Okay. So therefore it is not affected here. So what here? y5 is wrong now here. We will correct it. We will correct it. Okay. So what here? Minus 2. Okay. So now y fourth derivative. Y fourth derivative. Then plus y prime y third derivative. Okay. We have to apply the product rule. Minus 6 y prime y third derivative. Minus 6 y third derivative plus y prime double prime square now. So this is equal to minus 2 y fourth derivative, and see this is what? Minus 2 minus 6. So this will be minus 8 y prime third derivative. Okay. And minus 6 y double prime square. Okay. Now we'll find y naught fifth derivative is what? Minus 2 y naught fourth derivative minus 8 y naught third derivative minus 6 y naught square. So this is equal to 2 times y naught is 1. Then the fourth derivative is what? Fourth derivative. Just to calculate, this is 34. This is what? 34. Minus 8 into y naught prime is minus 1. And y naught third derivative is minus 8. This is minus 8. Then minus 6 y naught, this is 3. So 3 square. So this is what? So this is minus. Okay. Minus. So minus 68. Minus 64. Minus 40. Minus 54. So minus 168. You get minus 168 now. Okay. So minus 168. Okay. Now we put here in 1. We'll put these values in 1. Okay. So this is your 1. So 1 implies y of x. What is your y naught? Y naught is 1 plus x. What is your y naught prime? Y naught prime is minus 1. We'll write in the value in bracket. 1 upon 2 factorial x square. What is your y naught double prime? Y naught double prime is 3 now. So 3 plus 1 upon 3 factorial x cube. What is your y naught? Third derivative. This is minus 8. Plus plus 1 upon 4 factorial x raised to 4. What is your fourth derivative? Your fourth derivative is 34. Your fourth derivative is 34 plus 1 upon 5 factorial x to the power 5 minus 168 plus dot 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 plus dot dot dot. Okay, so right, so you may keep this as it is or you may simplify this. If you want to simplify, you can simplify. So it's right. Okay, if you want, this is 2 factorial and this, if you are interested, then you can do this one. Okay, so we'll do this one. So this is what 1 minus x. This is 2 factorial means plus 3 by 2 x square. This 3 factorial means 2 into 3. So 2 into 3, that is minus 4 by 3, then minus 4 by 3 x cube. So 4 factorial is here now, and this is what 34. So 2, that is what 17, then 17 by, is it plus? Yes, plus 17 by 12 x to the power 4. Then minus here, I will write this 168 upon 5 factorial as it is. I will not simplify this, dot dot dot. Okay. Okay, so this is the solution of the given differential equation. Okay, so now we have to find the value of y.1 up to 4 decimal places. Just I will write here what 0.1 plus 3 by 2 0.1 square minus 4 by 3 0.1 raised to 3 plus 17 by 12 0.1 raised to 4 plus 17 by 12 point raised to 4 would be. Okay, up to 4 decimal places you have to find this one. Okay, so with the help of scientific calculator you can do this. So it will be 0.9138. 0.1938. I hope that you understand this one, how to solve this. Okay, so we'll solve one more problem so that the idea will be clear to you. Here the crucial part is what? To take a derivative. Okay, so to take the correct derivative. So this is the crucial part. We'll solve one more problem. So that you will understand the Taylor series method. Okay, so we'll do this. Okay, example. Okay, so solve dy by dx is equal to 1 plus xy with initial condition y of 0 is equal to 1 by the command is given to you. Okay, by Taylor's, in exam the method will be given to you. Okay, so by Taylor series method and find y of 0.1 correct to 4 decimal places. Okay, solution. Given that solution. Okay, given that dy by dx is equal to this with initial condition y of 0. So therefore what? So x naught is 0, y naught is 1. Y prime is equal to 1 plus xy. Okay. So by Taylor's series method, y of x is equal to y naught plus x minus x naught y naught prime plus 1 upon 2 factorial x minus x naught square y naught prime plus 1 upon 3 factorial x minus x naught cube third derivative plus 1 upon 4 factorial x minus x naught raised to 4 y naught raised to y naught derivative so the fourth derivative at y naught plus dot dot dot. Okay, so here x is 0, x is 0. Okay, so x naught is 0, x is 0 means x naught is 0. Okay, so therefore we have y of x is equal to, just we'll write this y of x. Okay, no, we'll write here y of x is what, y naught plus x y naught prime plus 1 upon 2 factorial x, just x square, because x naught is 0 you are putting that. So you can put it later on also while putting this value, that also you can do this one. Okay, so y x naught, this will x y naught double prime plus this is square 3 factorial x cube y naught third derivative plus 1 upon 5 factorial, correct. This is the fourth derivative at y naught plus dot dot. I will call this as 1. Okay, so now I am interested to find the values of y naught prime, and so on. I will put the values of this. I will get a solution of the given differential equation. I will get a solution, or you may say this as 1 and this will what, 2, this will be 2. So I will find the values of y naught prime and this one. I will put these values again in 2. I will get the solution of the differential equation 1. And if I put what, y of 0.1, you want y of 0.1. If you put x is equal to 0.1 everywhere, you will get the y of the value of y at 0.1. Okay, so we'll find this now. Okay, so now your y naught, here y naught is what, y naught is 1. Okay, so your y prime you have 1 plus xy. Therefore y naught prime we will find, y naught prime. So y naught prime is what? Okay, so what we will do? So y naught prime, this implies that. Okay, so y naught prime is equal to 1. Your x is what? Your x is 0. X is 0. So 0 into y. Y is what? So 1. So y prime is 1 now. Initial y. This is x naught y naught. Okay. Okay. So now we'll find y prime now. Y double prime. And we'll find y naught double prime now here. So we'll differentiate. This is 0. X y prime plus y prime. Okay. So derivative. This implies that y naught double prime is equal to what? X naught. This is what? X naught y prime plus y prime plus this is y, not y prime. This is y. Is y naught. So this is what? X naught is 0. So this is what then? Y naught. This is what? 0. Y naught prime. This is y naught prime is 1 plus 1. So this is 1. It will be the 1. It will be the 1. Okay. So we find y third derivative now. Third derivative. Okay. So this x will be as it is, y double prime plus y double prime plus y double prime. Okay. So this is what? X y double prime plus 2y prime. Plus 2y prime. Here we have applied the product rule. Okay. X as it is, derivative of y is y double prime plus y prime as it is, derivative of x is 1 and derivative of y is y double prime. Okay. So now this implies that third derivative will be what here? X naught y naught double prime plus 2 y naught prime plus 2 y naught prime. What is your x naught? It is very nice now. This is what? Your x naught is 0. What is your y? This is 1 plus 2. What is your y naught prime? Your y naught prime is 1. So 1. So this is what? 2. So this is 2. Okay. Now we will find the fourth derivative. Actually we get this is the first term, second term, third term. Up to fourth term it is up to fourth or 5 term it is okay. So this will be what? 1, 2, 3. Actually we get a fourth term. Okay, no problem. So we will find this fourth derivative and then we will stop. Okay. So now this will what? So derivative of this one we have to do this one. So derivative of x. This is the third derivative plus y second derivative plus 2y second derivative. So this is what? X. This is third derivative plus thrice y third derivative plus thrice y derivative. So then this is what? The fourth derivative will be what? X naught third derivative at y naught plus 3 second derivative at y naught is equal to. So first one is 0. No, we will not write anything now because what your x is not is 0. Then 3 into y naught double prime. What is your y naught? Y naught double prime is 1 now. So this is what 3 into 1. So this is 3 now. It is 3. Okay. Okay. So we'll find the fourth derivative also, fifth derivative also. Okay. We'll find that. We'll find the fifth derivative also. We'll find for our knowledge. We will find this one, fifth derivative. Okay, for our knowledge. Okay, so now this is what x, y, fourth derivative, y, fourth derivative, plus y, third derivative, plus 3y, third derivative, plus 3y. Okay, so this is equal to what then? This is x, y, fourth derivative, plus 4, third derivative. Okay, so now we'll write. So this is what the fourth derivative, fifth derivative is equal to what? This will be 0 plus 4. Third derivative is what? Third derivative, fourth derivative. This is the fourth derivative. We are differentiating this. See here what? Oh, this is third derivative. Okay, this is third derivative. Your third derivative is 2 now. Oh, we got this one. Okay, so this is what the third derivative. Third derivative is 2 now. Third derivative is 2 now. Okay, third derivative 2. This will be 8 now. This will be 8. This will be 8 now. Okay, so we'll put here now. Okay, so your 2 implies now. 2 implies. 2 implies. So what we get 2 is this. Okay, so y of x is equal to, what is your y naught? Is 1 plus x plus x. What is your y naught prime? Your y naught prime is 1 now, plus 1 upon 2 factorial x square. What is your y naught double prime? Your y naught double prime is 1 now, plus 1 upon 3 factorial x cube. What is your third derivative? Is 2 now. Third derivative is 2, plus 1 upon 4 factorial x to the power 4. What is your fourth derivative? Is 3 now, plus 1 upon 5 factorial x to the power 5, 8, plus dot dot dot, plus 8, plus dot dot dot. Okay, so you will get this as it is. Okay, so this is, so I'll simplify this. 1 plus x plus 1 upon 2 factorial x square, plus this is, we can write 1 by 2. Okay, no problem, 1 by 2. Here we can write 1 by 3 x cube, plus here you can write this is 1 by 8 now, because 3 get cancelled. So this is x raised to 4, plus, so 5 factorial. So 5 into 4 into 3 into 2. So this is what the 4 a get. So this is 1 upon 15 x to the power 5, plus dot dot dot, 1 upon 15, all this. Okay, so this is the solution of equation 1. This is y of x. Okay, y of x. This is solution of equation 1. Now you have to find y of point 1 now. You have to find y of point 1. So this is what? 1 plus point 1 plus 1 half point 1 square plus 1 by 3 plus 1 by 3 point 1 cube plus 1 by 8 point 1 raised to 4. Okay, it is enough now. So the value will be 1.1053. Okay, okay. So this is very simple. Only the crucial part is what? You have to differentiate this. So it is enough to take the fourth derivative. Actually, for our convenience, we have taken the fifth derivative. Actually, no need to take the fifth derivative. So at least you should get 5 terms. first four or five terms. Okay, so that means here actually we don't need to find the fifth derivative. Okay, so my suggestion is what? So differentiate it up to the 4 times only. Okay, so I hope that you understand as well. You are able to solve any problems on the Taylor series. Only the crucial part is what? You have to differentiate this. You have to find the derivative of that one. For practice, you do the practice on it, so that you are able to solve the number of problems. Okay, so I hope that you understand all those things here. So now we will stop here. Thank you.